There are two kinds of problems involving derivatives and inverses. There are the problems where you can find the inverse explicitly, and then there are problems where you can't find the inverse explicitly. The ones where you can't find the inverse explicitly will be the focus of this video. You do need to know a couple of things about inverses if you're going to understand this. One is how to find an inverse. If you're given a function like y equals something like the square root of x minus 1, to find the inverse you would first switch x and y and solve for y. So we could do that with this one, but it's not the focus of the video, but you do need to understand that that's how it works. Another thing that you need to know about a function and its inverse is the graphical relationship they have. Now, if you graph a function and its inverse on the same set of axes, you find that they are reflections about the line y equals x. So if f of x looked like, say, this, its inverse would look something like, maybe like this. Alright, reflections about the line y equals x. Now, for purposes of doing this video, I'm not going to write f inverse. Whenever you see a g of x, when you see g of x, you should assume that I'm talking about f inverse of x. Right? So g of x equals f inverse of x for purposes of this video. The reason being is because we're going to be taking derivatives, and I just don't like writing f inverse prime. So once again, where you see g, you should always assume that it means f inverse. Alright, so along with this graph, another thing that you need to understand with this graph is the correspondence of points from one to the other. If there's a point on, I guess I'll call this one f. If this point here is, say, 3, 0, then there's a corresponding point on g with the coordinates switched, 0, 3. And so on and so forth for all these things. That's how we got the inverse. You get the inverse by switching the x and the y. So there's always this correspondence of these points here. And if I just highlight another one, I want to point out something that's also of interest here. If we have another one here, say, let's suppose that this point is I don't know, 4, 6, then that would mean that there is another point. There's a corresponding point on the inverse that would have to be 6, 4. Now that means another way of interpreting that is that if this is going to be f, that means that f of 4 equals 6. That's a 4. And if f of 4 is 6, if you know that f of 4 is 6, then it must be the case that g of 6, or f inverse of 6, must equal 4. This is very important. This relationship is sort of primary to our understanding of how to take derivatives of inverses. Because oftentimes this is what's going to happen. We're going to be confronted with some kind of a situation. Let me just redraw this up again. Let's say here will be, this will be f, and this will be g. So I'll label them. That's g, and this one will be f. What's going to happen is we are going to want g prime of some number here. And let's say that this number is like 8. Alright, the problems are all going to we're going to need g prime of 8. And in order for us to know that, we are going to need what g of 8 is. So if you need g of 8, you can find it by setting f of x equal to 8. Right? Because if g of 8 is some number x, then f of that number must be 8. Alright? And if this is what we need, if g of 8 is what we need, if x is what we need, then setting f equal to 8 and solving for x will give that value to us. There's going to be more on that later if that's unclear. But the main relationship that you're going to need is this. Now, typically these problems come to you like so. They will say, it'll be something like, they'll say f of x equals x cubed plus x. Notice if you switch x and y, you won't be able to isolate y. But they'll say f of x is x cubed plus x. Find g prime of 10. So find the derivative of the inverse of f at x equals 10. Alright. Assuming that the problem comes to you this way, which they usually do, you're always going to want to have one piece of information, at least one piece of information handy before you even get started. And that's going to be the y. You're going to need the y coordinate on G that corresponds to x equaling whatever number they gave you. So in this case, it's going to be 10. All right? You're going to need the y coordinate on G. Yeah, that corresponds to x equaling 10. Sorry if that's sloppy. So the first thing that you're going to want to do before you even get started on these is when they ask you for g prime of 10, the way that you should interpret that is, I'm going to move this out of the, I'm going to flip this here. Let me see here. Let me just rewrite that again. If f equals x cubed plus x, and they want g prime of 10, immediately you should think of it like this. The problem involves, now we don't need to know what f and g look like exactly. I'm just going to say, suppose that this is f, and then if that's the case, this will be g. Alright? So what this is asking for is it's saying that there's some point on G at x is 10. Right here. They want g prime of 10. They want the slope of this line. It's going to be necessary that we know what the y coordinate of that point is. For each of these, there are 3 methods of solving these, and for each one, you're going to need to know what that y coordinate is. So, if there's a point, I'll say, if I say on G, there's the point 10, I'll call it B. The way that you figure that out is 10, B. If you know that on G there's 10, B, then on F there must be the point B, 10 by virtue of the fact that they're inverses. So as soon as you get these things, you know that you're going to need that value of B. I'll tell you why in a minute, but you have to realize it from now. So to figure it out, if 10, B is on G, then B, 10 must be on F. And to figure out what that is, this must mean that f of B equals 10. And we can figure out what that value of B is by setting f equal to 10, right? We would say if f of B is 10, then since f of x is x cubed plus x, we would set that equal to 10 and figure out what the value of B is. It might take a little bit of a guess and check thing, but for purposes of doing this video, all of these, when it gets to this part, everything is going to be easy. I have to solve this, so if I just plug in a couple numbers and guess and check, I'm going to come up with the right answer. If I plug in 2, I get 2 cubed is 8, plus 2 is 10, so I know that f of 2 is 10. Therefore, the point that I'm looking for, the mystery y value, is 2. This would be 10, 2, for example. You're going to need to do that in every one of these problems. Alright? So when they give you this, you should immediately say, okay, I'm going to set f of x equal to 10 so I can get that y value corresponding to x being 10 on G. I know that that's a mouthful, but if you do a few of these, it'll become routine and it actually won't be so bad. Like I said, there are 3 methods of doing these inverse problems, and they all more or less look like this. They will give you f and they'll ask you for g prime of some number. I will do an example of each method, all of which are equivalent, and but I just have to keep in mind that before doing each, you have to do this critical thing first. Before we're even talking about what the method is, the problem is going to be this. Alright, f of x is this, and we want g prime of 10. You realize that it's an inverse problem, so the first thing that you want to do is set f equal to 10. And you get x cubed plus x equals 10. So you solve this, and you get x is 2. So what this means is that on G, there's the point 10, 2, because on F there was the point 2, 10, right? Because f of 2 is 10. Now, this is how method 1 goes. The first method is the straight up method, just from the definition of inverses. If you take f and you compose it with G, its inverse, what you're going to get is x back. Alright, f of f inverse should give you x because they're inverses, they undo each other. Now, if we differentiate this, what's it going to give us? It's going to give us, by the chain rule, it'll be f prime of g of x times g prime of x equals 1. And if you rearrange this, you pull this down to the other side, you get basically what is the equation for method 1. G prime of x equals the reciprocal of f prime of g of x. Alright, this in a nutshell is method 1. Remembering this equation, remembering where it comes from. So, this is also why we needed to figure out our points from the beginning. Because now, if the problem is asking for g prime of 10. So using this, I can just say g prime of 10 equals 1 over f prime of g of 10. But what is g of 10? Well, that's why we had to get it from the beginning. G prime of 10, g of 10 is 2. So really, g prime of 10 is 1 over f prime of 2. So f prime is something we can figure out. So all that we got to do to get g prime of 10 is to take the derivative of f, which is easy, flip it, and plug in 2. So I'll finish this off. This started out with f of x was x cubed plus x. So f prime is 3x squared plus 1. All we have to do is plug in x equals 2 for that. And that'll give you 2 times 2 is 4, times 3 is 12, plus 1 is 13. And according to the method, all that you have to do is flip that. So g prime of 10 is 1 over f prime of 2, which in this case happens to be 1/13. And that's it. As long as you can remember this, and so long as you get this point in advance, you won't have to worry about it when you do this method. So that is method 1. Straight up, comes right out of the definition of an inverse. Method 2 involves, which I'm going to work on this, involves the geometric relationship between a function and its inverse. So once again, here's the problem. Here's f. They want g prime of 6. Before I even do anything, I'm going to find the y value on g that corresponds to x being 6. So I set f equal to 6, 3x squared plus 2x plus 1 equals 6. This is really the hardest part of these. Sorry about that. This is really the hardest part of these problems here, is solving this equation. Now I'm making them easy because I don't want to get held up on the algebra in the course of doing this video. So my answers are always going to be easy, and hopefully if you ever have to take a test on these, this will be easy for you as well. But to solve this equation, I just plug in a few numbers. It's kind of a guess and check thing. If I plug in 1, right, I get 3 plus 2 plus 1 is 6. So x equals 1. So that means that, I just want to write this down again. That means that on G, there's the point 6, 1, and so, or because of, on F, there's the point 1, 6. Now, to method 2. Method 2 involves it's like a graphical approach. It basically gives you the same result and is the same thing as method 1, only sort of from a geometric perspective. We're going to capitalize on the fact that the functions are that f and its inverse are reflections about the line y equals x rather. So if this is a graph of f, call that f, and this is the would have to be the graph of g. Again, I'm using something simple here because I don't need to complicate it up. But we are interested in g prime of 6. So here's 6. The thing is, alright, I'm just going to use a geometric argument here. G prime of 6 is this slope. Now, there's a point, we already found that it corresponds, this point here would be 6, 1, which corresponds to the other point on F, which would have to be 1, 6. Now, just from looking at this, what do you think the relationship is between the derivative of f at 1 and the derivative of g at 6? Turns out they are reciprocals. What we get out of this is that I always say that if there's some point a comma b, if there's a comma b on f, that must mean that there's b comma a on g. And f prime of a is the reciprocal of g prime of b. So the way that I write that out is g prime of b equals 1 over f prime of a. So the derivative switch, it's the reciprocal relationship, but you have to switch the x's and y's too. So this is basically, from the graph, is a method 2. So what this says here, like b and a are the 6 and the 1. So what this is saying is, once you have this, if you can understand this from the geometric relationship between f and its inverse g, and you know this, all that you need, if you want g prime of 6, that's going to be 1 over f prime of 1. Basically, it's the same thing the same as method 1, only just a little different of a justification for it. But that makes it easy because all that you need to do is differentiate f. So that's going to be 9x squared plus 2. Let me see. So that'll be f prime of 1 is 9x squared plus 2, or 1 over 9x squared plus 2, evaluated when x is 1. And so plug 1 into that, and you get 9 times 1 is 9, plus 2 is 11, and the slope is g prime of 6 is 1/11. Now notice this was made a lot easier because we found this point in advance. All right? In advance of doing all this and coming up with this relationship, which was basically the same as in method 1, we knew this, so we didn't have to go like hunt for it. We understood that we were going to use it somewhere in the problem, and there it is. That's how it all kind of comes together. That's method 2. Method 3 uses implicit differentiation. And again, I'm going to do that first step. So here's f of x, and they want g prime of 7. So the first thing I do is find the corresponding y coordinate by setting f equal to -7. I get x cubed minus 5x minus 1 equals -7. And because I made these easy, I like to play, it can't be that hard to solve because I want to get moving on this. If I plug in 1, it doesn't work. I plug in 2, it doesn't work. But if I keep on trying, negative 1 works, right? Negative 1 cubed, wait a minute, it was, oh, sorry, it was plus 5x, yeah. Negative 1 cubed is minus 1, minus 5 is minus 6, minus 1 is minus 7. So in this case, the x is minus 1. So I'll write down again, I'll say on G, there's the point minus 7, minus 1. And therefore, on F, there's the point minus 1, minus 7. So now we can proceed with method 3. Method 3 involves implicit differentiation. We're going to take this, and instead of f of x, I'm going to write it as y equals x cubed plus 5x minus 1. Now, in the course of finding an inverse, what we would do is we would switch up x and y and try to isolate y. So that's kind of what we're going to do. We're going to switch x and y. X equals y cubed plus 5y minus 1. And you notice that you can't isolate y. But even though you can't isolate y, that doesn't matter. Y, in this case, by virtue of the fact that they were switched, y is still the inverse of x. So what we're going to do is we're going to differentiate this with respect to x implicitly. So differentiate both sides. The derivative of x, I'll write that out, d dx. Alright, I abuse the notation, I do it on both sides. The derivative of x is 1 equals 3y squared dy dx plus 5 dy dx. dy dx. Alright. Factor out a dy dx and divide through by the 3y squared plus 5, and you get dy dx equals 1 over, there's the 1 over again, 3y squared plus 5. This is method 3. Alright, because this dy dx, this y, is f inverse. So this is really g prime. The only thing is, it's given in terms of the y coordinate, which fortunately we found from the very beginning. Right? That's why we had to find it first for all three methods. So this is g prime. It's just not given in terms of the x coordinate. So that's why we found the y coordinate from the beginning. We know, since we wanted g prime of -7, we know that the y value that corresponds to x being -7 on G is -1. I'll say that again. Because we wanted G prime of -7. But we can't evaluate that. We can't plug that -7 in here because there are no x's. We need the y coordinate on G that corresponds to x equaling -7. We already found it from the beginning, so once we get here, since we already found it, all we got to do is plug in the -1. And the -1 value for y, plugging that in, y is -1. That gives you 3 times -1 squared is 3, plus 5 is 1/8. And that is method 3. Notice all three methods were aided by the fact that we first found the corresponding y value. I can't emphasize that enough. As long as you understand that you need that going into this, it's not going to be a problem. But that's basically it. They all three are equivalent. I would ask you to try maybe to go back to the first problem and try the other two methods on it. Try the graphical one and the implicit one on this one, and try the straight up method and the implicit method on this, and then try the straight up method and the graphical method on this just to verify that all three methods give you the same answer. And as a bonus, I have a couple of other questions that don't follow this exact pattern of giving you the function and just simply wanting g prime. But we're still going to use these principles that we talked about in figuring these out. Here's one of them. All right. This one's actually pretty easy though. It says, all right, if f of 4 is 5 and f prime of 4 is 2/3, what is g prime of 5? Well, if you remember back from method 2, we said that g prime of A was 1 over f prime of B. This is what we needed. So, what this is saying is that g prime of 5 is going to be 1 over f prime of the value of y that corresponds with x being 5 on g prime. Let me just write that out again, just to emphasize that we are doing the second method here. If this, I'll say, if this is f and this is g, all right, here's that. All right, this is f and g. The correspondence here, all right, g prime of A, which is this thing here, g prime of A was 1 over f prime of B, the other value. But from the given information, they said that f of 4 is 5. Therefore, g of 5 must be 4. Hence, on g, there must be the point 5, 4. So the 4 is what we're after here. All right, and now we know that g prime of 5 is 1 over f prime of 4. Notice I gave you f prime of 4, so that's going to be 1 over 2/3 or 3/2. Every one of these problems uses this principle to some extent, and you'll always be given what you need, right? If you weren't given this, then if you didn't know that 4 was the point that corresponded to x being 5 on g prime, then you would have no way of doing this. That's how it goes. And the last one I have is a little bit more complicated. I define a function big G by the reciprocal of small g. And then I say, if f of 3 is 2, and f prime of 3 is 1/9, what is g prime of 2? Well, before we get into this, since f and little g are inverses, right away I'm going to say that since f of 3 is 2, that g of 2 has to be 3. Alright, just going to keep that on the back burner there, and we're probably going to need it. And so it wants g prime of 2. So before I find big G prime of 2, I have to differentiate big G. Need a little chain rule. So G prime, big G prime of x equals, I'll need the chain rule, the reciprocal, that's minus 1 over G of x quantity squared by the chain rule times G prime of x. Alright, and if I clean that up, that's minus G prime of x over G of x quantity squared. So what I need to do is let x equal 2 for this, and that'll give me G prime of 2, right? G prime of 2, follow through, right in here. So what I need here is, if I can move this down, I need G prime of 2, and I need G of 2. Alright, G prime of 2, G of 2 we already know. We know that G of 2 is 3 because we know that f of 3 is 2, and they're inverses. So G of 2 is 3, and I can fill that in. And I also know from the last problem and from method 2 that G prime of 2 is 1 over f prime of something. What is that something? In this case, it's 3, right? G prime of 2 is 1 over f prime of 3, and we were given f prime of 3 is 1/9. So this is 1 over 1/9, or 9. And once we have G prime of 2 and we have G of 2, all we have to do is plug it in, and that'll be minus G prime of 2 was 9 divided by G prime of x squared, G of x squared, which is 3 squared. And so the answer, G prime of 2, when you finally plug it in and work it out, is -1.